unless you can cancel from every single term, don't cancel. In other words, I have an x in 3 out of the 5 terms. Can I reduce everything by x? No. Okay? So be careful about your canceling. The first thing you want to do is factor. Factor, pardon me, the numerator factor the denominator. That's why we had a warm up of factoring. So, on this one, what does my numerator factor to? X minus and my denominator becomes, it's the difference of perfect squares, correct? So x plus 3 and? Okay, so we factored. Now, look for common factors to cancel. In other words, what exists in the numerator and the denominator? So we can't cancel if we're adding. And unless we can take out of every single term. But when we're multiplying, if we're multiplying by something in the top and something in the bottom, none of those reduce. Okay? So what am I multiplying the top and the bottom by? X plus 3. So they reduce out. And then simplify your answer. Simplify the numerator and the denominator. So this reduces down to x minus 5 over. Do the x's cancel? No. Because it's not appearing in every single term, and I'm not showing multiplication, right? I'm showing either addition or subtraction. Are you with me? Make sense? So you've got to be good at factoring. Okay? You really need to be strong with your factoring. Alright, what do I factor on this numerator? What does it factor to? 2 and good.
We have a weird box of like, you have a what? Like a box like where the extra would go.
There should be a little box. Okay. Alright, what's my denominator factor to?
X plus 3 and X plus 1.
Does anything cancel? Does anything cancel? Your factors have to be identical. Number and sign. Nothing cancels, therefore, nope, therefore this stays 2x minus 2 over x squared plus 4x plus 3. So I can't go back to the original. Okay. Next one. What do I factor out? Or what do I factor? 20 up on top leaves me with 2x minus 1. Remember, for factoring, we're pulling something out of every term, and that you can't lose one of those terms. What does my denominator cancel or reduce to?
And X minus 3.
Is that correct? Okay, so can I do anything with the 2x minus 1? How about with the x minus 3? What about the 20 over the 10? What reduces there? The 10. So I'm left with 2 times 2x minus 1 over 1 times x minus 3. So that's just 2 times 2x minus 1 over x minus. So let me quickly check. I'm thinking that the book keeps it in factor form and it does. So you don't really have to multiply it.
Wait, so I think I'm going to reduce them onto like all of them.
Remember multiplication.
Oh, right.
Right? If you're showing multiplication, you can do some canceling. If you're showing just strictly adding and subtracting, then there's nothing you can cancel. Okay?
Why did we take a 10 out of the denominator in the first place?
I did. I pulled it out. The first step has to be factoring so that you're showing products so that you can do some canceling.
Oh, it has to be. Oh, this one. I forgot to put this one outside of the.
Okay? Alright? Pay What is this denominator going to factor to? So remember the box method? If you didn't like this, you can do the long way, do the box method. Remember, we put 3x squared here and 5 here. And then we did 15, that gives me, and so the factors of 15 are, that gives me 16. So what do we put here? Nope, 16x and 1x. What do I pull out here? And what do I pull out here? It's an x, correct? What do I pull out this way? 3x. What do I pull out this way? A 1. So what are my factors? What cancels? What am I left with? Very good. The x's cancel.
No.
Because they don't appear in every term, right? If you have initially factored correctly at the very beginning, your final answer cannot be reduced any further. Okay? Alright? Let's do this. Can I factor the numerator?
No.
So it stays there. Can I factor the denominator? What is it? What reduces? So what's my answer? 1. That's why I put this one here. Anything over itself is what? 1. We're not subtracting them, Abby. We're canceling them. 1 over x minus 4.
Oh, I get it.
Okay. Okay?
What's the class method like?
Huh? Well, it's the factoring part of it. Alright? What does this factor to?
Minus 3x plus 1.
Okay? This one doesn't. Yeah, this one. Yeah, let's make this 6x and then it comes out 3. Thank you. Okay, so this is gonna, how is this gonna factor if I make that just a 6x?
Plus 1 is plus 5.
What cancels?
4x plus 1.
What am I left with? Are you following this? Emily, how you doing with this? Or you furiously are writing? Are we all okay on this stuff? Haley, yes? You're good? Alright, so when we multiply, we're going to want to do the same thing first. We're going to want to factor, and then we're going to want to cancel common factors. So it's like reducing your fraction, and then we're going to multiply back out. Multiply the remainders out.
Why do you multiply the remainder?
I'll show you what I mean. I'll show you what. We're going to multiply what's left. Numerator times numerator, denominator times denominator. Okay. So this first fraction's numerator, how do I factor that? 3x, 1 minus x. What's this denominator factor to? Times. What's this factor to? And my denominator stays 3x. No, it's going to be a negative 1 and a positive 5, which is a positive 4, right?
Yeah. So in these, can you cancel like this, so that you also cancel like this?
Sure, exactly. Think about when you were doing first learning canceling with fractions. 3 over 5 times 6 over 9 times 5 over 12. Couldn't you cancel all the way across any numerator with any denominator?
Yeah.
That's what they identical? No. We'll come back to that in a second, though. All right? What can cancel? The what? X plus 5. And the 3x with the... They're not saying the same thing. This is not saying x minus 1. But, can I pull out a negative sign? Yes, it's a 4. Can't I pull out a negative sign? Out of this term. If I pull out a negative, then I would have negative 1 plus x, which is x minus 1. What's the point of doing that?
Well, then you do it on the bottom.
No.
Oh, you don't want that.
Okay.
So would you just, so would those cancel?
Now they cancel, and we're left with a negative sign there. Does that make sense?
So that's just negative and then x minus 4.
X minus 4 over 1, right? So now these cancel, and I'm left with negative parentheses, x minus 4.
Leslie, you took out the negative sign.
I knew that these were identical except for their signs were backwards. So when they're identical except for their signs, you can pull out a negative sign, because if we distribute that negative sign, don't we get what we started with? We're just rewriting the way it looks. Does that make sense? Okay.
So do we keep it as negative x minus 4?
Probably, now, I'm real picky. There is a big difference between that and this. So make sure that negative sign is the negative of whatever's left. We cannot write it like that. Okay? You need a lot of parentheses in this problem. Okay. This one's much easier. Do we understand that it's like taking a fraction 8 halves and 7 fourths, and we're just multiplying all these variables? Yes? We're going to use our rules for exponents. Okay? Let's cancel out our numbers first. The 2 can go into what? The 2 can't go into the 4.
And the 4 and
The 2 can go into the 8 how many times? And then can't the 4 go into the 4? Right? And so what I really have up top is a coefficient of 7, because that's the only number that exists after all of my canceling, yes? I'm putting them all together because I'm just multiplying. This is like the last chapter. Now, on the numerator, what is my exponent of my x going to be?
7.
Okay? And on my y? I'm just putting them together. I'm using my rules for exponents. Okay? In the denominator, I have no number. My exponent for my x stays what?
X.
And on my y? Are you all with me? Now, Sandy? I took the 2 into the 8,
And what happens to that 4?
and then that 4 goes into that 4.
Oh, okay.
Better?
I'm just confused about why you shouldn't do that with 7 or 4. Does it matter? Like, I could, because on the stuff before, because when I was like reducing the numbers, I also just reduced the x's, like,
Yes.
subtract 1x from the bottom. And
If you see that, do it. But for the majority of people, this will be easier this way. Okay? All right. I can't have the variables appearing in the numerator and the denominator, which means I can simplify, yes? So what does this simplify to? Where? Up top or down low? And what about my y? Y to the first or just y? Now there's multiple ways you could have done this. Okay? You could have done what Rachel said, made this x squared, made this y down below, right? Made this x to the fourth and y squared, and then do your manipulating of your variables. You'll get the same answer. Okay? All right. Here we go. Emily, you had your hand up kind of up and down?
no, I figured it out.
Good. Okay. All right. What do we know about when we divide by fractions? We multiply by the reciprocal. Which one do we multiply by? The first one or the second one? We flip the second one, don't we? When we divide by a fraction, we take the original one we multiply by the reciprocal of that second fraction. We say x squared minus 6x plus 8 over x squared minus 2x. Y'all with me? And now this is a problem like we've done before. What should be the first thing that I be doing? Factoring. So this becomes 4x over what?
5 times
Yes. Times, what does this numerator become? Factors of 8 that give me 6. And 4. So x and x, 2 and 4 gives me 8 and 6. How do I get positive 8 but negative 6?
Make it belong to my
Make it both negative, right? Okay, what is my denominator factor to? Okay, now we look for common factors that exist in the numerator and the denominator, and we cancel them. What is one that you see? X minus 4 and the x minus 2. And this x and this x. Why would it become 3x? Because I'm multiplying, I'm not subtracting. And so what am I left with in the numerator? And the denominator? Yeah,
That's so weird.
I think that all of us became 4/5.
Yeah.
So you cancel with that.
I can't. I've got 4 times x and I have the x in the bottom, so the x is reduced. So they're not subtracting because they're not exponents, right? Okay. This stays 2x plus, 2x squared plus 3x minus 5 over 6x. And then this becomes what? Yes, good. And so this numerator, do you want me to do the box method? Yeah, alright. So the box method says I have a 2x squared and a negative 5. My product is negative 10 and my sum is 3.
Oh,
5 and negative 2. So negative 2x and positive 5x. Agreed? Pulling out what? Negative 1. Remember when that top one is negative, we're pulling out a negative sign with it. And here we're pulling out a x, here a 2x, and here a. And so this becomes x minus 1 times 2x plus 5. Agreed? This is 6x. This is a 1. And what does this become? Yeah, so what cancels? Top I'm left with. And down below? 6x squared. So 6x times x is 6x squared. How we do it?
Oh wait, there's X's on the bottom and the top, is there something you can do about that?
Does it exist in every single function, and am I showing multiplication so I can cancel? So remember, Abby, if I had correctly factored everything and found all my factors that I can cancel, my final answer should not be able to be reduced any further. Okay? Neutral. using my colors to help me. So I did,
And I know you came up with 3 and 9.
I got 3.
I'm gonna pull it on there and see, but then I don't hear. And I know you, but don't you just add the numerators and the denominators?
Multiply. So I have an x to the 5th and an x to the times an x to the 3rd. Isn't that an x to the 8th? And then up here I got a y squared and a y, which is a y cubed. And down here, that's 4, right? And then I have an x and an x to the 3rd, which is this, and if this becomes this. Now remember, in our final answer, variables can't appear more than 1.
Oh, okay, that's.
So then this gets reduced, and this
Okay,
gets
I thought that was a multiplication sign there, but I.
No, that's a equal. So I'm taking this and reducing it, and then this. In a couple minutes, we're going to go through this next example, and then you can go. Because I want you to be able to recognize you got soap. You've got to think of soap in these problems as a possibility. This stays x plus 5. This becomes x. Which means, guess what happens? They cancel.